Okay, this is lesson 50, geometric mean. We're going to go over the theorem first, 50-1. It says if the altitude, now let me stop there. This right here is the altitude, okay? If it's drawn to the hypotenuse of a right triangle, so you see this right triangle, the big one? It's drawn to the hypotenuse of a right triangle. Then we know that the two triangles formed, so see how this made two triangles, are similar to each other and to the original. So let me go slow, and I'm going to be explaining this right here.
Okay.
All right, so let's first look at this one. It's saying JKM, so that's this small one, is similar to LMK, the other small one. So once again, this small is similar to this small. Okay, now let's examine this middle similarity right here, where it says JMK, so JMK, the small one, is similar to JKL. That's the big one.
Okay.
Okay, and then the other side, it's pretty much saying that this one is similar to the big one. Okay, so here I go. Small one similar to small one similar to big one, and small one similar to big one. So there's three triangles going on, and they're all similar to each other.
Got it.
Okay. Now, this is what a homework question might look like. It says find PS and PQ. Now, PS, which I'm going to highlight just so we can draw our attention to it, is right here. And I'll use a different color to highlight PQ. So those are the sides that we're trying to find. Now, in the same way that these triangles are similar to each other, that's what's going on here. The challenge is going to be to examine all three triangles and see how we can find a relationship. This is what I mean. The first thing I'm going to do to help our eyes out is to draw the right symbol here, because that helps me find the hypotenuse. Do you see how if I look across there, that's the hypotenuse? If I look across there, that's the hypotenuse. And watch me, if I look across here, that's the hypotenuse. So all the hypotenuses go together. All the short, so this is the short leg of this one. This is the short leg of this one. And this is the short leg of this one.
Okay.
So all the short legs go together. All the hypotenuses go together. All the long legs, so that's the long leg of this triangle. This is the long leg of this triangle. And this is the long leg of this triangle. So again, the challenge is going to be training your eyes to see what parts go with which parts. So if we were to start with, let's say, PS, okay? PS, so long, compared to short, see right here, is the same as long is to short. Please tell me if I lost you.
So long is short. I don't think you did.
I didn't lose you?
No.
Okay, so let me write it out in letters. Long, so that's PS, is to short 4. Long, so here, long is to short as long
Oh, I get it now.
is to short.
Got it. So then it would be 4/3, and then you
Yes.
just do cross multiply.
Correct. So 3PS equals 16, right? We're going to be cross multiplying. And if we punch that in our calculator, we're going to get 5.3 repeating. Double check it.
3PS.
So divide 16 by 3 in your calculator.
16 divided by 3 equals 15.3 over, or 3.
5 shouldn't be 5.3.
Or not over, 15 point, or, whoa, what? Not 15. 5.3.
Yes.
With a line over it.
Perfect. So make sure you write that down in your notes. Okay, now we're not done. We solved for PS.
But not PQ.
But not PQ. Okay, now let's examine. All right. Okay, do you see how this is the hypotenuse of this triangle?
The PQ is
This is the hypotenuse of this.
Yeah, because it's longer than everything else.
So hypotenuse to short leg is the same as hypotenuse to short leg.
Okay.
Because you see this guy right here?
So that's a hypotenuse is a 5.
Yeah, this is the hypotenuse and this is the short leg. So now let me write it out, what we just highlighted. So I think I said hypotenuse, which is PQ, and then the short leg is 4, equals hypotenuse 5, short leg 3. So I had to find a pattern. All right, now we cross multiply. We get 3 PQ equal to 20. Punch that in for me. 20 divided by 3. And tell me what PQ equals.
6.6.
Yep.
7.
Good. So we're going to write 6.6 repeating.
Okay.
But if you, on your homework, you wrote 3.67, I mean, same thing. I'm not going to count that wrong. It's close enough. Okay. So now we've answered PQ. All right, moving down to geometric mean. So let's go over the definition of that real quick. Geometric mean. For positive numbers A and B, so they're going to give you 2 numbers to work with.
Okay.
The positive number x such that you're going to use this proportion right here. See how they put the A and the B diagonal and the 2 x's diagonal?
Right.
So we're going to do that with this question right here. And in your homework, it'll actually say the words geometric mean. So when you hear geometric mean, I want you to think of this thing right here.
Would it be A over 3?
Well, A is your 3. So this is your A, and this is your B.
Okay, so then it would be 3 over x.
Yep.
Equals, sorry, not 12, x over 12.
Perfect. Now remember, x times x is x squared. Please don't put 2x, it's x squared. And then 3 times 12.
36.
Yep, take the square root of both sides. X equals 6. All right, now this is when it works out beautifully. See how we got a pretty number there? Let's look over here where it's not going to be necessarily a pretty number, but nothing we can't handle. Notice how we're asked to find the geometric mean of 2 and 9, but this time they want us to round to 1 decimal place, and they want us to give the answer as a simplified radical. But we're going to start off doing the same exact thing. We're going to set it up as 2 over x, right? Because that's going to be our A. And then x over 9, because 9 is going to be our B. And we're just going to do the same thing. It's going to be x squared equal to 18. Take the square root of both sides, punch that in your calculator, and round to 1 decimal place since they said tenths.
4.2.
Very good. 4.2. So be careful on your homework. Make sure you answer it the way they ask for it. Okay, now part B. This time they want us to make a tree of 18, and they want us to rewrite this as a simplified radical.
So just 18, and then it would be 9 and 2.
9 and 2.
And 3.
And 3 and 3.
So 3 would come out, and then you would radical.
Very good. 3 root 2. Nice. That's the answer there. Okay, bottom left. This is one of those that are still geometric mean, but this time it's written as those overlapping triangles. I'm going to draw in my right angle symbol. So you'll notice that this leg is to this leg as this leg is to this leg. That's why it's going to be one of those geometric means, because it's going to be 3 over y is equal to y over 4/3. Well,
so it's going to be a little...
Yeah, y times y is y squared, and 3 times 4/3 is 4. So when you take the square root of 4, you get y equal to 2.
So that looks difficult, but it's not difficult.
Exactly. It looks difficult, but it's not difficult.
Okay.
All right, last one on this page says find the missing values of A and B. Now, you have to be careful because this one is like the one up here that we were working on. Okay, so you have to, again, take a minute to really examine what's going on. I'm going to start by highlighting what they asked for. So they asked for A and they asked for B.
So if they're asking for A and they're asking for B, would you would you put the X rather than would you put the X 3 and 4, or is it still just A and B?
It's still A and B. I would use those as my variables, but I need to see what's happening here. So first of all, it's nice to take a look and say, okay, look, they gave me all the sides of the big.
Mm-hmm.
Notice how there's a 3, a 4, and a 5. So I'm going to use that to my advantage. But first, if I'm solving for A, notice how it's short over hypotenuse,
Okay.
right? Because you see how I did my right angle right there?
Uh-huh.
I know the hypotenuse is across from it. So short over hypotenuse is the same as short over hypotenuse of the big, this big. Okay, good. So your eyes can see that? That's good. So I'm going to write down short over hypotenuse is equal to short over hypotenuse. A over 3 is equal to 3 over 5. So then we cross multiply, and I'm just gonna leave it as 9/5, but if you wanted to punch it in, you could write 1.8. I'll take either one. All right, why don't you give B a try? See if you can name that as either short over hypotenuse or long over whatever short, and compare it to the numbers that they give you for the big triangle.
Okay. So let's see. Hypotenuse is 4, right?
It is, especially, excuse me,
Because of the 90-degree angle.
if you're looking at this,
Mhm.
you're right. 4 is the hypotenuse. So what would be? Is that the short or the long?
That's a long.
Yeah. So long and hypotenuse is what I'm dealing with.
And then I want to find the big triangle of the hypotenuse.
Yeah.
So hypotenuse is 5?
Uh-huh. And which one's the long?
4.
There you go.
So it would be B over 4.
I agree. Hold on, let me write it with you. B over 4.
And then 5 over 4? Or wait, no. Yeah. 4 over 5.
4 over 5. Good, you corrected yourself. Because I noticed your pattern. You did long over hypotenuse. So I better do long over hypotenuse.
Right.
Yeah, because you caught the pattern matters.
5B and 16.
Yep, 5b equals 16.
And then can I just put 5 over 16, or would you, or 16 over 5? Or
Yes. I'll take 16 over 5, and if you're just dying to punch it in, 3.2 is the answer as well. So fraction form or decimal form, either one I'm happy with as long as it's accurate. Okay, let's move on to lesson 51, which is properties of isosceles and equilateral triangles, one of my favorite lessons because it's just so straightforward and easy to understand. Okay, so first some definitions. We have leg of an isosceles triangle. So what we need to fill in for that, it's that it's one of two congruent sides of the triangle. So if you look over here, do you notice these two sides are congruent on this isosceles triangle?
Right.
Well, that makes this a leg and this a leg because it's one of the two congruent sides.
And then it's just a hypotenuse at the bottom.
Well, not the hypotenuse because that's for right triangles. This isn't a right triangle, but we'll get to what that's called here in a second. So next is the vertex angle of an isosceles, and that's an angle formed by the legs. of the isosceles triangle. So back here, you remember how I said these are the legs?
Mm-hmm.
Well, the vertex angle would be formed by those two legs touching. So this right here is the vertex angle. Now, base. Base of an isosceles is the side opposite the vertex. So write in opposite. Once again, it said opposite the vertex is the base. So this was the vertex, correct? The vertex angle. So opposite of that is the base. So MN, that's the base of this isosceles triangle. And then lastly, we have base angle. So base angle is one of the two angles that have the base of the triangle as a side. So fill that in, base and side. So if this is the base, then these are the base angles.
Mm-hmm.
And they're always going to be,
Congruent.
yeah, congruent. So it's always going to be this one and this one. Okay? These two lower ones right here. All right, so those are called base angles. Now let's look at a theorem real quick, 51-1. It says if a triangle is isosceles, then its base angles are congruent, like you just said, Grady. So since LMN is isosceles, we know that angle M is congruent to angle N. So I'm going to go ahead and just fill that in so that way when you look back, you know that that's true. All right, I want you to highlight this for me. This is very important right here in asterisks. It says in all equilateral triangles are isosceles, but not all isosceles triangles are equilateral. So it's kind of one of those weird statements where like all squares are rectangles, but not all rectangles are squares. So first of all, let me refresh your memory in case you didn't know. This is called an isosceles triangle, an equilateral triangle. It's where all three sides are equal. So because the definition of an isosceles is that at least two sides are congruent, that's why this fits an isosceles.
Ah.
But look at this one. This one has two sides congruent, not all three.
Right.
That's why this is not equilateral, but this equilateral is isosceles. So,
Oh.
yeah, one can be the other, but the other not necessarily that one.
Mm-hmm.
Okay, now, these are kind of fun. It says find the unknown measures. Now, do you remember what we just talked about as far as if these two are then which two angles are congruent?
If those two are congruent, then the angle A and angle C are both congruent. So
Very good. And I love how you specified that by saying angle A and angle C. So if angle A is 50,
then angle C is 50.
agreed.
And then B would be the vertex, right?
Correct. B would be the vertex angle. And how do I find that? If these two are 50 and 50, how then can I find this?
Well, since they're both 50 and 50 and a triangle is 180 degrees, you would just add them and then do 180 minus 100, which would be 80.
Perfect. Perfect. You're right. All three angles have to add up to 180. That means angle B must be 80 because the other two are 100. All right. Now, this next one's asking me to find this side here. Well, they're trying to give me a hint by showing these two angles congruent.
So that would just mean that the top lines, you can just make those congruent and then 5 centimeters on the other side.
Very good. Add those two tick marks.
So it's basically like the opposite.
It is, but notice how they rotated it.
Mm-hmm.
They positioned it funny because we're used to seeing it like these up here, but then they turned it to its side thinking that it would confuse you, but you have to look for the hints.
Well, I just rotated it myself.
Oh,
I
perfect.
just rotated my paper
I like that.
to look at it.
Okay, now this one's equilateral. It's trying to tell us it has 3 equal sides, therefore it has 3 equal angles.
Oh, this is, I think, a little easy. You just take 180 and divide it by 3.
Bingo. 180 divided into 3 equal groups.
60.
60 degrees. Voila. You just got to use some number sense, math sense. They're like puzzles. You have to apply what you know. So go ahead, talk me through this one.
46 is congruent to x because of the lines.
Perfect.
And then you add 46 and 46
Yep.
to get 92. And then you take 180 minus 92. That would equal to 88.
Perfect.
So now you
Too
know
easy.
why.
Okay, talk me through this one then.
Let's see here. That would mean, let's see, the vertex is 40.
Correct.
Oh, wait. I would just take, since those two angles are congruent, you would just take 180 minus 40, then divide whatever. I got 140. Divide 140 by 2. And then that would be your answer, right?
Correct.
70.
70 for both. I love it. You're on a roll. Go and tackle that last one then.
Okay. Flipping it over again. 63 is congruent to y. So you would write 63 for y, and then you would write 63 plus 63 equals 126, and then you would take 180 minus 126, and I got 54. So x is 54 and y is 63.
Perfect. Okay, bottom left. This one, they require you to draw it yourself. They're just going to give you some information in paragraph form. So it says if the vertex angle of an isosceles triangle measures 30 degrees, what are the measures of each of the base angles? So they expect you to know from the vocab that if I have this situation going on, right? And they're telling me that this right here is 30 degrees. They're asking me for the base angles.
So they're basically just you're meant to write it out.
Yes,
Okay.
they want you to draw it.
So then you would just do what I did on like the
That
fourth
middle
one, yeah.
bottom?
Yeah, that middle bottom. So you just take 30 or 180 minus 30 divided by 2.
180 minus 30, divide equally into two parts.
75.
Very good. So they're each 75 degrees. Good. Okay, I think you could tackle this one without me.
The perimeter of the triangle is 22 meters. Find the measures of the missing side lengths. 22 meters. Perimeter is all the sides added up. So let's see here. You would take, since that's congruent to that, I already know it's 6. 6 plus 6 is 12.
Agreed.
10 is a hypothesis, or hypotenuse. Perimeter is, what are they asking for? Find the measure of the missing sides. Done.
So that side right there.
10.
Yeah, very good. 22 minus 6 plus 6, which is in fact 10 meters and 6 meters. All right, too easy. Last lesson of the day, lesson 52, which has to do with properties of rectangles, rhombuses, and squares. So let me go over some facts about those that you're going to need to know to solve these problems. So property 52-1 says the diagonals, remember diagonals are these things right here. The diagonals of a rectangle are congruent. So PR is congruent to QS. Easy enough. 52-2, the diagonals of a rhombus are perpendicular. So you notice that right angle right there? So be very careful. Don't confuse the properties of a rectangle with the properties of a rhombus. Okay? Diagonals are congruent, not here. They're not congruent here. They're perpendicular here. Okay? And be careful, they're not perpendicular here. You notice all kinds of acute and obtuse angles going on there.
Right.
So don't confuse the two. All right. Property 52-3, each diagonal of a rhombus bisects opposite angles. So you'll notice this diagonal bisects these into two equal, and this diagonal bisects these two into equal. Therefore, angle 1, 2, 5, and 6, so 1, 2, 5, and 6, all of those are congruent.
Right.
And then angle 3, 4, 7, and 8, those are all congruent in a rhombus.
Oh, okay. Yeah, so you could just basically read it off though, because if
You
you look
can.
at it, you see 1, 2, 6, 5 on that side. So then you just write down angle 1, 2, 3, or not 3, 5, 6 is all congruent, and then you just do the same thing with the other one.
Absolutely. Okay, let's work a problem. It says a rectangular barn door has diagonal braces. So you see that right there? AE is 6 feet, so we're going to label that here in a second. What is the length of BD? Okay, so they said that this is 6 feet. Well, if that's 6 feet, we know this is 6 feet, correct?
Mm.
And in a rectangle, we know what about their diagonals? That very first property on the top of the
They're
page?
congruent.
Yes. So if this is how many feet?
12 feet.
12 feet. Then we know BD is
12 feet.
exactly.
Oh, wait. So that's easy.
So BD is 12 feet. All right, now we're looking at a rhombus, so be careful. We're going to apply the rhombus properties. Okay, so it says BCDF is a rhombus. They're telling us for a fact. So that we know this is a rhombus. They want us to find the measure of each angle. Okay, so this one right here, EBC. So let me find it. EBC. So this right here we'll have to plug in later. And then ECD, so ECD. So this one we'll have to plug in later to find the answer to this one. All right. Now, first of all, what do we know about the diagonals of a rhombus, particularly that second property at the top of your page?
They're perpendicular.
Yeah, they're perpendicular. That's kind of important. So go ahead and put in a right angle symbol right there. And I'm going to highlight this so you know exactly what we're looking at. We only want our eyes to see that triangle right there.
Okay.
What do you know about all 3 angles of a triangle?
The base, leg, and hypotenuse.
Tell me more. Like, what do the angles add up to?
Oh, 180.
180. So technically, couldn't I do this plus this equal to 180?
Yeah.
So that's how we're going to set that up algebraically. We're going to write down 3x plus 12 plus x plus 10 plus 90 equals 180. Now we're going to carefully combine like terms.
3x and then regular x. So that would be 4x.
4x.
12 and 10 is 22.
Mm-hmm.
And then
Plus the 90
is 1. Why am I blanking? 112.
Mm-hmm.
And then equal, and then you subtract that 112 from here. Subtract it from there. That would be 58, and then 58 divided by 4 would be 14.5.
Oh, wait, it should be prettier than that.
It should be?
Let's check our work.
Am I forgetting to add something?
I don't know. Let me see. Punch in your calculator. 180, take out 112. Maybe it's 68.
180 minus 122. Or wait, I see what I did wrong.
Because 68 divided by 4 is pretty. Punch that in.
No, I know what I did wrong. I did that 68, yeah.
Okay, so should we box that x equals 17?
No, because that's not what they're asking for.
Correct. They didn't ask me what x equals. They asked me what these 2 particular angles equal.
So then you would plug in the 17 for
There and there. So plug a 17 in there.
51 plus 12 now, and then that would be
So 3
63.
times 17 plus 12.
63, and then now that's still not the answer. You would just do now 63 plus 90.
So you're saying this is 63. No, because they want this angle right here. So that's 63 degrees. Right? Angle EBC.
Oh, I get.
Angle
Yeah.
EBC. So they want this.
Got it. I got it now.
And then when we plug in 17 to angle ECB, which is what they want down here,
It would be just 27.
27. Okay, and that's this batch of lessons.